In this video, we're going to look at how we can manipulate pointers. Pointers have their own very specific kind of arithmetic, so I'm calling this video Pointer Arithmetic. I'm going to begin by just declaring some variables, so you can see that I've got some variables here that I've used in previous videos already, and I'm going to use the technique I did with the introduction to pointers to initialize them. So I've got some regular variables, and I'm going to declare pointers to those variables, and then I'm going to take the address of the variable to initialize the pointer. Okay, so I have, for example, the variable age, which is set to 30. Then I'm going to declare an unsigned integer, which is a pointer to age. Then I'm going to take the address of age using the address operator, and I'll use that address to initialize pointer age. And I'll do the same thing for those other three variables. So that sets things up. So we need some pointers in order to look at how we can do pointer arithmetic. The other thing you'll notice in this code is I've got something here called skip2 that shows up quite a bit. And I got tired of writing a cout statement to skip a couple of lines. So I just used a pound define in order to declare that thing. So at the top, I just have a pound define, and here is my identifier called skip2. Whatever follows the identifier will be used wherever skip2 appears in the program. So I'm going to declare skip2 to be cout inline with a semicolon. So whenever you see that in the code down below, you can substitute the cout with two end lines. And you can use that pound define for anything that you want. So it's pretty neat. Now, let's get into it. Can we add and subtract with pointers? Well, there are some things we can do and some things we can't. So let's look at what I mean by that. And I'm going to use my typical technique here, where I'm going to just copy and paste some code from a different window into our visual window here, our visible window, and then we'll talk about the code. So I'm going to go ahead and paste the code in. And the first thing that I'll do is I need to print out some of the values for the pointer so that we can see how they're changing. So let's look at this one. I have pointer number that I'm going to use. So up here, I have the pointer number is an integer, so it points to an integer, and I'm initializing it to the address of number so that if I dereference it, then I'll get 7. So I'm going to have then the variable pointer number, and I'm going to print out what it contains, and I'm going to print out what it points to. Now, pointer number is a pointer. It's a memory address. So a pointer is a special variable that contains a memory address. I'm going to add one to that. Wow. So what is going on with that? Well, this is the preliminary state without having changed pointer number at all. Then I'm going to add 1 to pointer number. Then let's print out how it's changed. So let's just take this cout statement and let's just copy it. I'm going to copy it, now I'm going to paste it right down below. And then, so that we don't get the other output, I'm going to include a system pause right here. So I'll go ahead and type that in. Now that I've done that, let's run the program and let's see what happens when we add 1 to pointer number. So I'm just going to compile and run the program. Looking at the output, I can bring this over, and from the first line, let's see if I can change things around a little bit here. Let's scroll that up, and we'll put this here. Okay, so for the first cout statement, we have pointer number, and we have the value pointer number, which is this address. So that's what pointer number contains. And since it is the pointer to number, then when we dereference it over here, we get the value 7. Now, I'm going to add 1. When I do pointer number is pointer number plus 1, then that just adds 1. So when I print out with the second cout statement, I print out pointer number, and you'll notice that it's a difference of 4. So this part is the same, OOFCF9F. Then there's a 4 here. Up there is a 0. Then afterwards, there's a big negative number, which I do not know what that is. Okay, it means nothing to me. We would, in computer science terms, call that garbage. But what I have done is to add 1 to an address, and then I dereference that new address and print out what is stored there. So you can do that with pointers. That's an extremely powerful thing. You could not do that with regular variables. Now, whoops, that's the wrong thing. Let's bring up our output window again. Okay, there it is. Now, the reason that I get a difference of 4 whenever I'm adding 1 up here is that this is a byte addressable memory, as you may recall from the video a while back, so that each byte in the word has its own address. When I add 1, this is adding one entire word which contains 4 bytes. So that means I'm moving forward by 4 addresses instead of just 1. So 4 bytes is equal to 1 word, and that is that's what I'm adding to here. I'm adding 1 additional word or 4 bytes. And that's determined by the type. Okay, pointer number points to an integer. Okay, pointer number is a pointer to an integer, and an integer takes 4 bytes of storage. So when I add 1, I'm adding 4 full bytes of storage. So that's why you'll see the number change from a 0 here to a 4 there. So I'm adding on 4 bytes. All right, so it did work. It gave me some output, even though this is nonsensical output here. Now let's move on and let's continue with this addition, and let's see if we can add something other than 1 to our pointer value. So I'm just going to take this line of code and we'll add 5 this time. So let's take the value pointer number. I've already added 1 up there, and I'm going to add 5 to it this time. Now let's print out the value of the new address, pointer number plus 5, and let's print out what it points to. So I'm going to copy and paste again, and we will print out the new address here, and we'll print out what it points to over there. All right, now let's go ahead and compile and run the program. We'll bring in the output, and let's scroll down so we can see it. Okay, again, I still got that window. Don't want that window. Here's the output. Now let's look at the output we get this time. Okay, so the first line, the first cout statement up there, that just printed out the address of number and what the address is used to dereference the pointer, and we get to the value 7. So here's the address of the variable number, and here's what it contains, 7. We added 4 bytes previously when we just added 1, and then we saw that we had some garbage show up there. This time I'm adding 5. Alrighty, well, that's 5 times 4 bytes, so it's a total of 20 addresses that I'm adding on. So we go from, and I know this is hexadecimal, so it's kind of hard to count, but we're going from C4 all the way up to D8, and that's actually 20 locations that we're adding on. And when I dereference that, you can see over here, I dereference that, and I'm dereferencing this new address. I added 5, there's the new address. When I dereference it, I get this thing, and I don't really know what that is either. But the point here is that you can add numbers onto addresses. So that's pretty amazing. So we can take an address in memory, we can add some offset to that address, and then we can dereference it to see what's stored there. Pretty wild. Well, if we can add, then can we subtract? And I think you probably can guess that the answer is yes, that we can subtract. So let's just do a subtraction then. So I'm going to put a subtraction in here. So it's okay, and this time I'm going to use pointer number -2. So I'm going to subtract 2 words, and that would be a total of 8 bytes. Now, I'm going to also print out, I'll just make a copy of that line again and paste it down here, and we will print out what we get. So, so far I've started with pointer number, I've added 1, then I added another 5, so that gives us a total of 24 bytes. Then I'm going to subtract 2, so that's going to take off 8, so that would be 16 bytes. But you can see we're manipulating the address over here. So we can add and we can subtract this address, and then we can dereference that new address to see what's stored there. Well, let's compile another program and see what we get this time. We have the output, and if we bring this over, then you can see that the subtraction also works. So we start out, here's number, it's 7. We add 4 bytes and we get that, which is unknown. We add 20 more bytes, we get that. Over here, this is what we get. And then finally, when we subtract 2 off of that, then here's the value we get. Now, let's look at this subtract. We can figure this out pretty easily. Before we subtract, then we had this as the address that was stored in pointer number. Then if we subtract 2, then that's pretty easy. We've got an 8 here. So 2 words is 8 bytes. So we subtract 8, then our new address is going to be 70. So we have subtracted from the address, and whatever's stored there is shown here. All right, well, we can add and we can subtract. That works out great. Are you getting a little tired of seeing these hexadecimal numbers? They're hard to read, aren't they? Before we go on, let's see if we can change that so that we can print those out in decimal. So I'm going to make that small correction, and then we'll recompile the program. We're printing out the address here each time. Pointer number, that contains the address. We're printing that out over and over. If you want to see it in decimal, then we have to change the type. Remember, a pointer is a special type. It's not an integer, it's not a float. It is a special type, which is a pointer. So we can't just use the int and the hex and the dec and the oct that you saw in previous videos. But we can change the type. We can use our type coercion operator. So instead of just having pointer number here, if we use parentheses and we change that to an integer, then what that does is it takes this thing, which is a pointer type, and it temporarily changes it to an integer type. And by default, integers are printed out in base 10. So let's use that at the beginning of these addresses for all 4 of them. And that will let us see the address as a base 10 number. All right, now I'm going to compile and run the program, and we should have numbers that are now much easier to read. I'll bring over the output window. And now you can see that those addresses do show up as base 10 numbers. There are no hexadecimal digits in there at all. So it makes it easier for us to do the calculations. So when I added on 4 the first time, we've gone from 48 to 52 here. So that adds 4 bytes or 1 word. Then when I added 5 to 52, that was 5 times 4 bytes for a total of 20. So now we go to 72. And then when I subtract 2, we subtract 8, so we go back to 64 there. So that makes it much easier for us to be able to calculate the sizes and the changes in the addresses. So from now on, I'm going to use that technique so we can see a base 10 number for the addresses. So first question, can we add and subtract? Yes, we can. You can take a pointer and you can add some offset to that, or you can subtract an offset to that. Okay, now what about increment and decrement? Well, I'm going to give you the punchline. Sure, you can increment and decrement, because if you can add one, we can use the shorthand notation to do that. So let's just put some examples in here so that we can demonstrate the increment and the decrement operators with addresses. I have moved the system pause down here. And now we're going to place some code right here to demonstrate increment and decrement. So let's try to use pointer age this time. So pointer age, I'm using it because we changed pointer number up here to something different. So we ended up with an address that was different than what we began with. So let's start over with pointer age. And let's also just put the integer in front of that so that we can see it as a base 10 number when we print it out. So let's print out the preliminary unchanged value for pointer age. So here it is, that's the name, and here is the address it contains. And over here, we will print out what it points to. Okay, now I'm going to increment that just using the ++ increment operator. So the question is, can we increment? Yes, we can increment. So now this will add 1 to the address pointer age. Now let's print out what is stored there. Okay, so I'm just going to copy that line and I'll paste it, and we'll look at what we have after we've added 1 by using the plus plus operator to pointer age. All right, now you know that I'm going to also do this again with prefix notation. So I'm going to go ahead and put that in here as well to show you that both of those work. So let's look at the prefix increment as well as the postfix. So that's post, and this is prefix increment. Then I'm going to let's see. I'm going to print out the output again afterwards. So I need to get the cout statement for that. So I'll copy that and we'll paste it in here so we can see the changes as we go. Okay, so I think I just put that in the wrong place. So now I have that doubled up. So let's delete that. All right. Okay, so what we have now is we have the original pointer age. We'll print out what it is and what it points to. So the age is going to be 30 up here, so it should print out 30. Then we are going to add 1 to the address of pointer age, and we will print out what it points to. Let's move that over there. Okay, so we'll print out what the new address points to. Then I'm going to increment it again, but I'm going to use the prefix form of the increment, and then I'm going to output that. All right, now let's go ahead and let's go ahead and put the plus plus over here so that we know which one is which. Now let's compile and run the program. We can look at the output, and here's what we have. So for the increment and the decrement part, then we have pointer age to begin with, and that's a really big location. Look at that address. Okay, 400, so it's 11,533,400. So that's a pretty big address for pointer age. And it points to the variable age, and when we dereference it and print it out, we get 30. So you know how to do that now. Now I'm going to add 1 to that. So you can see that we really did. We've added 4 bytes to the 00 here. So now we add 1, we get 4 bytes beyond that. And when I dereference that, then there's this big number stored there. Again, I don't know what that is. It's garbage. I can also use the pre-increment and have that work. So in this case, we add on 4 more. So it goes from 4 to 8. Okay, so we had 4 there. We increment again with the increment operator, we get 8. And then when we dereference now that new address, then I get that, which coincidentally is the same number that I had at location 404 up here. So I get those two. So that's, again, you don't know what that is. I don't know what it is. But the point is that you can use the increment operators within your code to change the value of a memory address. Well, if we can increment, then we must be able to decrement as well. So let's prove that we can do that by putting in some code that will decrement using the minus minus operator. Now we'll put the code in, and now I'm going to decrement the pointer. So we can use the minus minus to do the post decrement, and we can pre-decrement with the minus minus on the left. So this should bring us back to where we started. So we will decrement once and decrement twice, and we will print out the addresses, and we'll print out what's stored there. So now let's compile and run the program to show that this does work. Bringing over the output, then you can see that it does. So we started out with pointer age here at, in this case, after running it this time, the address is 85,177,32. So we incremented, we go to 36. We increment again, we go to 40. Then I'm going to decrement. So if I decrement, that's going to subtract 1 word or 4 bytes. So I've changed the address back to 36 and print out this garbage again. But when I decrement one more time, it goes back to the original address of 732 up here, 732. So when I decrement that, it prints out the value 30 because now it's gone back. So I increment twice, and then I decrement twice, and I'm back to the original address. So you can see then that we can use our increment and our decrement operators with pointers. Now let's see if we can do some regular addition, like can we subtract pointers. Let's try that. I've moved the system pause down here, and I'm going to keep on doing that as we go through these examples. So let's suppose we want to subtract 2 pointers. So let's put some code here that would do that. So I'll paste this in, and let's take pointer number and pointer value, and I'll go ahead and print those numbers out. So we'll print out address pointer number and address pointer value. Then we're going to subtract them. We'll subtract the pointers, so we're going to take pointer value minus pointer number if we can. Does the system allow us to do that? All right, well, let's compile and run the program to find out for sure if it does. Looking at the output now, we see that pointer number, in this case, we're back to the big address again, 11,532,288. That's where pointer number is. Pointer value is here. So pointer value is going to be less than pointer number. Pointer number has an 88 and value 60. All right, so can we subtract them? Yes, we subtract and we get a -7. That's the difference between them there. So there's seven words. So 4 times 7 is 28, right? Because this is the number of integers that we are subtracting. And remember, an integer is 4 bytes. So a difference of 7 means we have 4 times 7 bytes difference. So it's going to give us a -28. So if we took that, if we did the 88 number up here, pointer value is less than that, so we get a negative number. Say pointer value minus pointer number gives us -28 bytes or -7 words. So that's how we get that. So yes, you can subtract memory addresses, and it'll give you the difference between them. If we had switched this around, pointer number minus pointer value, we'd have gotten a +7 there. Now, can you add pointers together? Let's try that. So I know this is titled, subtract pointers, but let's see if we can add pointers while we're here. So let's paste in another line here. We're going to add pointers, and we're going to add pointer number plus pointer value. And you can tell that we have this red underscore here, which in Visual Studio is an error. So that would give us a compilation error. So we cannot add them. So here's your first exception when you're talking about pointer arithmetic is you cannot add 2 pointer values together. It's just not allowed by the system. It won't let you compile it. And you can understand that. If we looked at those values, when we did print out the pointer number and pointer value before, they were really big numbers, big addresses, like 11 million plus. So if you added them together, you're going to get a gigantic number. And the system is set up so that it will not allow you to do that because most likely that large number is going to be somewhere outside your program space. And the operating system isn't going to let your program move outside of its designated memory space. So that's why you can't add. It would very likely put your program outside of its allotted memory space, and it might cause some errors because if you were to be able to do this, and you could get into another address which might be somebody else's program, or it could be in the operating system. Anyway, it's outside your allotted area, and it's not allowed. We can't do it. So we have to just comment that out, or we could take it out altogether. So you cannot add pointer values. However, subtraction is okay. If you're subtracting between a couple of pointer values, of memory addresses, then the difference between those addresses is small. It's a small number. So you're allowed to do that. Now, I've been using constant values up here. We added a 5 or we subtracted a 2, and for the increment and decrement, we just added 1 or subtracted 1. Can we use variables to do the same kind of thing? So let's experiment with that here. Can we add and subtract using a variable? Well, let's move the system pause down, and let's put some code in here to see if that kind of thing is allowed. Well, let's put in a line of code here that will do a subtraction. So let's go ahead and paste that in, and I'm going to use pointer age again here. So to begin with, let's print out the value for pointer age. We can do that here. Then let's see if we can subtract the variable value from it. Okay, so we have pointer age minus value, and that's in parentheses. So if I can subtract, I'll convert that to an integer so we can see it as a base 10 number. value is just the number 5. Okay, so way up here we set value to 5. So that means what we're trying to do is use a variable to subtract off the value 5 from this pointer. So I don't see any red underscores, so we probably can do it. So let's go ahead and let's run the program and let's see what we get. And we can bring over the output window, and it's getting quite long here, but as you can see, we are able to subtract. So pointer age was this value here, that address, and value was 5. So 5 words contains 20 bytes. So after subtracting, I get 64. Okay, so it's 84 here minus 20 gives me 64. So yes, the answer is yes, I can use a variable here to do a subtraction away from the address of pointer age. So I can do that. Now, can we use a variable to add on? Well, we can paste in another line of code here, and instead of subtracting, then we can use a addition sign here, and we can add on whatever the number is that's in value, and then we'll try that over here. Now, okay, this does look like it'll work okay because there's no red underscores or anything here. So let's go ahead and run the program, and we can move that over. So here's what we get. So we started out the pointer age this time. Oh, that's a nice number, a nice 100 over here on the edge. So the initial pointer value for age is that value. And then if we want to subtract off 5, then we get an 080 there. And if we want to add back 5, then we go back. We take pointer age, which is this value. And if we want to add the value back, then this is what we get here. Okay, let's talk about that a bit more. The original location is 2018 3100. I'm not changing that value. I'm just adding an offset to it or subtracting it. So if I have this value as pointer age, and if I subtract off 5, then that gives me 20 bytes that I'm subtracting. That gives me 80. If I have this value as my starting value, and then I want to add 5 to it, then of course I'm adding on 20 bytes. So we add, and we get 120 here. So I was thinking that I had changed pointer age, but I didn't. I'm just adding to it in the bottom. I'm subtracting from it at the top. So this shows you that indeed you can have a variable where you can subtract off some offset, or you can add some offset. So that's fine. That's really not much more involved than when we're adding up here, just adding a constant number, or we're subtracting a constant number. So those numbers, instead of numbers, can be variables as well. So that works. Well, let's try to do this a different way. What if we had the following? Okay, what if we wanted to do the value on this side and then the pointer over here? All right, well, I need to change this, so I would have the pointer. No, I did that. Okay, so value is now on the left side and pointer is on the right. And you can see that's okay because addition is associative. So if we add pointer plus value there, then that's the same thing as adding value plus pointer here. So there's nothing wrong with that. But subtracting is a different story. You know, if we want to take this value which is 5, and we want to subtract the pointer from it, that would give us a gigantic negative number. And for the same reason that we had up above, the operating system is not going to allow you to wander out of your assigned space, and it's likely that this would let you, wander outside that range. For whatever reason, you can't do this. So we can't take like a constant, and really I think I've got a better explanation for that. The value is 5, right? The variable value contains 5. And if I subtract 11 million or whatever from it, that's a gigantic negative number, and negative addresses are not allowed. So that's the real reason. You can't have negative addresses. So addition's fine. Addition's associative, but of course you cannot do subtraction like that. So this one's not allowed. So let's comment that one out. Now, let's move on and look at some of these other possibilities. So there's quite a few left. So let's just go through them. So I'll move the system pause down to the next step. And a pointer may be assigned to another pointer of the same type. All right, so let's demonstrate that. So let's put a line of code in here. So when we put the code in, then I'm going to print out the value of pointer number and pointer value so we can see what they are to begin with. Then I'm going to set pointer number equal to pointer value. That is allowed as long as they are the same types. So pointer number and pointer value, let's check the type. So when we go up here, we have a declaration. They're both pointers to integers, so that's okay. We couldn't use pointer temp or we couldn't use pointer age because those are different types, so that would not be allowed. But as long as your pointers are pointing to the same type data, then you can assign one to the other. So we'll have the initial values, the addresses for pointer number and pointer value, and I do want to put that int in front so we can see it as a base 10 number. So let's do that here, and also down here. Okay, the last line will just print out what they point to. So when I assign pointer number the value pointer value, then they're pointing to the same thing. So even though I'm going to see pointer number here, and actually when I dereference it, when I dereference pointer number there and pointer value here, since I changed them to the same location, then they're both going to point out, they're both going to print out pointer value. So let's compile and run this program to demonstrate that. We'll bring over the output. So here we go. All right, so to begin with, pointer number is that address, pointer value is this one. So you can see they're different. Just look at the last two digits, okay, 48 and 20. So they're at different locations. Then I'm going to assign them to each other. I'll set pointer number equal to pointer value. So now pointer number and pointer value are going to be the same. Okay, so then they point to the same address. And you can see here's pointer number, here's pointer value. They point to the same thing because I just assigned them to be the same. And of course, if you dereference them, they're going to point to the same place, which will give you the value 5 this time. So you can then overwrite an address by doing it this way, because once I've done this, then I have overwritten pointer number. So now it's the same as pointer value. If I wanted to use pointer number, I can't use it again unless I go back and reset it. I would have to go back up here or use the same line and reset the pointer number to the address of number if I wanted to reset it back to that. So once you've overwritten it, like any other variable, then you can't get back to it unless you go back and reset it. All right, you can compare pointers. Let's move down and let's show that you can compare them. But there are limits as to how you can compare them. So let's put the code in here and see how that works. So let's paste in the code. You can see it here. So we can use an if statement to compare pointers. And again, they have to be the same type. So if pointer number is equal to pointer value, and you can compare them using the regular equality relational operator. And if they are equal, in this case, we'll print out that they're equal. And if they're not, then we'll print out that they're not. So you can use the equals operator for that, and we can also print out if they are not equal to each other. So let's first of all show that we can test to see if they're equal. So let's compile and run the program. Now we can look at the output. And sure enough, here's the result that we get. Pointers may be compared, and since I just set them to be equal up here, right there, then those two pointers are going to be equal, so this will be true, and it will print out pointer number and pointer value are equal. And we could print out those numbers if we wanted to there. But this shows you that you can use an if statement and you can compare them. Okay, now let's modify this, and we can also do a not equal. Okay, so we do a not equal, and that means we'd probably have to change this a little bit. So if they're not equal, we would print out, we need to interchange these statements, or we can just change it a little bit. I'll put the not here, and we'll take out the not down there. So that was pretty easy. So now we can use the not equal operator to compare them as well. So let's demonstrate that. So after changing that equal sign to a not equal sign, then it also works. So this says, again, since they are equal to each other, we get the pointer number and pointer value are equal. But I had changed that to the not equal operator. And since they are equal, we did get this cout statement here instead of the one at the top. So you can compare pointers. That's another feature that you can handle with pointers. And we're almost at the bottom of this. So let's move on and let's check a few other things. Before we go on, I should demonstrate that, if you're comparing pointers, that's not really the same thing as comparing the values. So let's put another test in here so that we can compare values. All right, so I'm going to pause shortly and go find the code for that. So let's put the code here. And notice in this instance, the if statement is using the dereferencing operator. Right? So this is saying if pointer number is equal to pointer age, that is the thing that it's pointing to. So this is comparing the values that are being pointed to, not the actual addresses of pointer number and pointer age. So if those happen to be the same, then we would print out that they are equal, and if they're not, then it would print out that they're not. So I guess let's change that to a not equal because pointer number and pointer age are totally different things, and I've not changed those. Age is 30 up here, and number is 7. So let's compare with a not equal, so we'll get an output. Okay, so we'll put a not equal there. And let's put a not here so we can see the output. So I know that those are not the same thing. Pointer number is 7, star pointer number is 7, star pointer age is 30. So you can, notice the difference. That's what I'm trying to point out here. Okay, in this case, we're actually comparing the addresses where these things are stored. Down here, we're comparing the numbers that the pointers are pointing to. So let's go ahead and compile the program and run it, and you'll see the difference here. Bringing over the output window, then you can see that we have the pointer number and pointer value are equal. Let's put this on the screen if I can get it there. Okay, so this is from that statement, right? Pointer number and pointer value are equal. But here, 5 is not equal to 30. So in this other if statement, I've got the dereferencing operator. So the thing that it points to is the value 5 in this case. And the thing that age points to is 30. So the things that they point to are not equal. So don't confuse the comparison of the actual addresses to the comparison of the things that are stored at those addresses. Be sure to make a note of that difference. Now we're down at the bottom here, so we don't have much longer to go. Thankfully, the video is getting quite long. So I'm going to move this down, and let's look at the multiply and divide with pointers. So this will go pretty quickly. Let's put some space here, and let's get some code to show that. So let's put some examples in here. So let's suppose we want to take our pointer value and multiply it by 2 and print that value out. Well, you can see that we get the red underscore, so the compiler is going to catch this and not allow it. Also, if we try to divide, that's not allowed either. So you cannot do subtraction. I'm sorry, you can do subtraction if we're subtracting off from the pointer. You cannot do multiplication, you cannot do division with these pointer values. So those operations are not allowed, just addition and subtraction only. So let's comment those out and leave them in there for reference. Now let's look at the last one, which says other illegal operations. I can just remove this system pause now altogether because we're at the end of the program and that last one's down there. So let's try a couple of other operations and see if they will work. So let's paste them in. And if you have a pointer and you want to try to assign it some constant value, then you get an error message here. So the compiler will not let you do that. So you cannot assign a constant to a pointer. Also, what's wrong with this one? Okay, I've got pointer age is equal to pointer number. Previously, I was able to assign pointers like that. That was allowed. But the reason that this gives me an error is because these are pointing to different types. Okay, pointer age is a pointer to an unsigned integer, whereas pointer number is a pointer to a regular integer. So that's a type mismatch. So even though a pointer is an address in memory, the compiler is going to check to make sure that the things that the pointers point to are of the same type. So we have a type mismatch, which is not allowed. So those are two additional things you cannot do. So let's go ahead and comment those out as well. And this one too. Okay, so that takes us through the entire program, so you can see the things that you can do and the things that you can't. So just to quickly summarize, you can offset the value of a memory address, that's a pointer. You can offset it by using a constant by either adding it or subtracting it. You can increment it or decrement it using the plus plus or the minus minus operation, so that's allowed. And you can subtract pointers like that. You can subtract pointers, but you cannot add two pointers together, so that's not allowed. We can use variables for our offset. So if we're subtracting, we can subtract off some variable that contains some number, some integer value, or we can add it on. You can also do addition. Since it is associative, you can add the value before the pointer. You get the same thing. But you can't take a value and subtract off a pointer because you get a big negative number. Then you can compare pointers. Well, first of all, you can assign a pointer to another pointer that points to the same type. So we can do that, and that'll be handy in the examples coming up. It's important to know that you can compare pointers. You can check to see if they're equal. You can check to see if they're not equal to each other. But we can't do multiplications. We can't do divisions. We can't use a constant to initialize a pointer, and we cannot assign a pointer to a pointer of a different type. So you should remember those rules. You will see them coming up again in the future. That covers pointer arithmetic. So we made it through this video, and I think it's time